You got fins to the left, fins to the right, and you're the only bait in town. So today we're talking about the best theorem of all, ladies and gentlemen. It is central to your knowledge of statistics. And if you don't know it, it will limit your abilities. Can you guess? It's the central limit theorem. I know, that's pretty exciting. So first of all, in order to understand a central limit theorem, you need to know what a sampling distribution is. So this is what I bring to you. What is a sampling distribution? So let's take a look at different sample sizes. So if you take a sample size of 1, that means you're taking a look at the population, right? And if you then averaged all of those together, if you average every single person together, you get the average of the population. Now suppose you took a bunch of samples of size 5, and then you averaged those together, and those averages you put into a distribution. Now imagine you took the same thing of size 25. So I want you to take a guess at what is going to happen to the histograms as the sample size increases. So you see the population in line 1, then sample size of n equals 5 in line 2, and in line 3 the sample size of n equals 25. So pause your video and take a guess at what those are. Okay, so with the sample size of n equals 5, let's backtrack a little bit. Notice that the data is closer together, so there is less spread. The reason this is happening is because each number is an average. So a sampling distribution is a distribution of averages of your data, which is pretty exciting. Now take a guess, now that you know that, what the sample of n equal, or what the sampling distribution of size n equals 25 would look like. And there you go. Notice that this distribution is now, well, what do we call something that looks like this? Yep, approximately normal. And that approximately normal distribution really helps us, so when we take a larger sample size, first of all, two things occur. We get less variability, and the distribution becomes approximately normal. So what does this matter? Or what does this have to do with the central limit theorem? Well, here's the idea. The central limit theorem is about sampling distributions. So as the sampling distribution, as your sample size gets larger and larger, the sampling distribution of the averages, so all those little averages, gets closer to a normal distribution. And I need to adjust this just a little bit. There's a bit of a typo. It's the sampling distribution of the averages, so I need to make sure I'm writing X bar right there. And that's a capital letter, capital X bar. So the population distribution is the distribution of X. A sampling distribution is a distribution of a bunch of averages that you get from that set. So how do you find the mean and standard deviation of sampling distributions? Well, for averages, the mean of the sampling distribution would be the average of the distribution. Let's back up just a couple ticks. Let's talk about this for a second. If you take a bunch of averages, and then you average those averages, you'd expect to have the average. Seems pretty intuitive. So that's why the average of your distributions for proportions and means is going to be the same. Then, if we're taking a look at the spread of those sampling distributions, so let's take a very close look at the standard deviation of these sampling distributions. Notice that in the numerator there is a divided by the square root of n. So as the n increases, this standard deviation decreases because you get a larger and larger denominator. Same thing over here for proportions. So this chart is really important, but it's also on your formula card. If you can't find these on the formula card, let me know.
Once again, all students who are assigned to the cafeteria for
Now there's an announcement going on. I hate it when announcements happen while I'm making a video. It's so frustrating. She's literally said this 35 times this morning. We get it. Well, actually, we probably don't get it. We're a bunch of tweens that can't listen to directions. Okay, onward. So if you need a hands-on activity, I've got a bunch of pennies, and there's this penny lab that will help you to identify sampling distributions and see the pattern there within. You don't have to do that if you feel like you understand the concept. If not, I think this would be a great idea for you to go through. So the rule of thumb, we can use a normal distribution for sampling distributions if n is greater than 25 for means. And for proportions, if we have both of these conditions are true, then we can use the central limit theorem to say that those sampling distributions are approximately normal. Well, resource is about to start, so that means our practice problems are going to have to be the next video. So take a look at this problem, and the next video is going to answer it. Isn't that exciting? It'll be like in the future, you'll hear the answer. But for me, it's going to be like 5 minutes from now, but it will be in your past. So I'm asking a question now, you hear in the future, and in the past it's answered. Whoa. Serious whoa.